I'm going to talk about the history of batteries. Batteries were invented in 1798 by Alessandro Volta. He created what is named a voltaic pile. What is a voltaic pile? A pile of copper zinc discs separated from each other by cardboard disc moistened with salt or acid solution. Alessandro Volta found that by taking paper or cloth out between zinc and silver, you could control the level of voltage. Now I'm going to talk a little about the history of batteries in the 1800s. By 1836, the Daniell cell was created by John F. Daniell. He developed a way to avoid corrosion of Volta's design using two electrolytes, copper sulfate and zinc sulfate. In 1868, George Leclanche invented what is named the Leclanche carbon zinc cell. He designed a wet cell, this leading to Dr. Carl Gassner's invention of the dry cell in 1881. By 1896, Columbia became the first battery available for purchase in the US. This was a dry cell battery created by National Carbon Company, which became Air-Ready, also known as today's famous Energizer Company. By 1898, Conrad Hubert invented the electric hand torch, also known as the flashlight. Next, I will talk about the evolution of batteries from the 1900s to 2000. In 1901, a battery named the alkaline storage was created by Thomas Edison. In 1955, the batteries for hearing aids were created. By 1958, the first rechargeable battery system was created by nickel-cadmium. In 1959, the first portable batteries were created. They were named cylindrical alkaline batteries. They were invented by Liu Uri while he worked at Air-Ready Battery Company. In 1964, Duracell was incorporated. By 1989, the first AAA alkaline battery, Air-Ready, known now as Energizer. Early 2000s, the Energizer Company introduced the next, the E2 titanium technology to deliver dependable power, the easy change for hearing aids, and the first AAA lithium battery, E2 lithium.
As you can see here, what we have a picture of right here is a battery of linked glass capacitors. Let me explain what we're looking at here through Benjamin Franklin. In 1749, Benjamin Franklin, the United States founding father, first used the term battery to describe a set of linked capacitors he used for his experiments with electricity. These capacitors were panels of glass coated with metal on each surface. These capacitors were charged with a static generator and discharged by touching metal to their electrode, linking them together, and a battery gave a stronger discharge, originally having the generic meaning of a group of two or more similar objects functioning together. As in an artillery battery, the term came to be used for volcanic piles and similar devices in which many electrical chemical cells were connected together in a matter of Franklin's capacitors. Today, even a single electrical chemical cell, i.e. a dried cell, is commonly called a battery. One of the first practical batteries was actually created by a British chemist named John Friedrich Daniel, who found a way to solve the hydrogen bubble problem in the biolic pile by using a second electrolyte to consume the hydrogen produced by the first. In 1836, he invented the Daniel cell, which consisted of a copper pot filled with a copper sulfide solution, in which was immersed in an unglazed earthenware container filled with sulfuric acid and a zinc electrorod. Without this barrier, when no current was drawn to the copper ions would drip to the zinc anode and undergo reduction without producing a current, which would destroy the battery's life.
There are two main types of batteries: primary cell batteries and secondary cell batteries. These batteries dominate the electrical world by their differentiating and useful features. Each battery type supports different environments and different uses that continue to exist every day within our lives. Primary cells differ from secondary cells through their one-use feature. These batteries are portable batteries created to be used once and discarded. These batteries are not rechargeable due to the irreversible electrochemical reaction within the battery cell. The process of these batteries is what makes primary cell batteries good for only one use. A primary cell's process is when the chemical reactions provided through its use finish up the chemicals given for power. The battery is then deemed to stop generating electricity, thus finishing off its energy after one single use. Primary cells use up electrolytes that are within absorbent material called a separator. A separator is an ion-permeable material that prevents electric contact between opposite polar electrodes within the same battery cell. A separator prevents free liquid electrolyte within the cell, thus earning primary cells its common name dry cells. Primary cells are used more for small objects, such as small household appliances. On the other hand, secondary cell batteries provide a more different use within the electrical world. Unlike primary cells, secondary cells are rechargeable. These cells can be discharged and recharged many times over, unlike primary cells, in which are fully charged for one use only. Secondary cells are rechargeable through its ability to reverse electrochemical reactions, in which it allows it to gain and store energy on a many occasion interval. More than one combination of electrode materials and electrolytes are used within secondary cells. Some examples include lead acid, nickel cadmium, nickel metal hydride, and lithium ion. Secondary cell batteries fall into two categories based on their intended use. One category of secondary cells are used as energy storage devices, providing energy on the dot. These cells are fully charged by being connected to a primary power source in which fulfilling its duty to provide immediate energy. Some examples that use this category of secondary cells include the emergency no-fail and standby power sources and stationary energy storage devices that require load leveling, a process in which the batteries store energy when the demand for it is low and input this stored energy when later demanded. Another category of secondary cells are secondary cells used in the form of primary cells, but have the ability to be recharged rather than losing energy on its first use. These are the more common types of secondary cells, and some examples that use this type of secondary cells include portable electronics and electric vehicles. Primary cell and secondary cell batteries exhibit a number of differences from each other. With primary cells, their battery structure is primarily intended to be used once. This meaning it comes with separable functions than secondary cells. The idea of a single battery life means that primary cells are sold in great quantity for lower initial costs, but in the long run they have a higher life cycle cost. This also means that they are disposable and can be replaced very easily. In their form, primary cells are lighter and much smaller, thus being able to be used within many small portable devices. They are more intended to be used for smaller energy usages. This meaning that they are not ideally suited for a heavier performance. But overall, they provide longer service per charge and a higher charge retention rate. Secondary cells, however, have a structure intending to be reused and to withstand greater battery life pressures. This meaning they are sold less in quantity at a higher cost, but in the long run, if charging is convenient and inexpensive, then they exhibit a lower life cycle cost. Their recharging ability makes it last longer without the need to dispose of them, unlike primary cells. Throughout their battery life, maintenance is required in order to ensure the battery is functioning and recharging properly. It is hard to come by replacements for secondary cells, and in order to obtain them, you must pre-order them immediately once they are launched in stock. Although they now recently come in smaller sizes as well, secondary cells are not typically used for smaller functions. Their structures is made to withstand great pressures, thus making them more suited for heavier performances rather than small devices. But unlike primary cells, they provide a shorter service per charge and a lower charge retention rate. Here are some examples of primary batteries. The first example is carbon-zinc cells. These are the lowest costing primary cells. They provide a low amount of power, but have a great lifespan and are well suited for things such as flashlights, remote controls, and clocks. Next, alkaline cells. These are the most commonly used and most popular primary cells. They provide more power than carbon-zinc cells and have an excellent lifespan. These apply to household appliances as well. Alkaline cells are mainly used within portable products such as MP3 players, toys, radios, digital cameras, and etc. Last, lithium cells. These cells are small coin-sized cells that provide great performance and have a long-lasting battery life. These cells are used in small objects such as watches, calculators, and cameras. They can be a great replacement to alkaline cells. There are many examples of secondary cells. The first example, rechargeable alkaline cells. These secondary cells come in the form of alkaline primary cells, but possess the useful feature of being able to be recharged. They are not toxic and can be disposed easily. Rechargeable alkaline cells can be similarly used in portable products that use alkaline primary cells, such as flashlights, radios, remote controls, and etc. Nickel-cadmium cells are secondary cells that can withstand a great temperature range and provide a long battery life, but it can only give a low runtime per charge. They are 15% toxic and have a 30% self-discharge rate. Self-discharge is a process within the battery that reduces stored charge energy of the battery, thus decreasing battery life. Nickel-cadmium batteries are used within medical devices, emergency lighting, and emergency power sources. Next, nickel metal hydride cells are a type of secondary cells that are the more updated version of nickel-cadmium batteries. These batteries provide the same voltage but 30% more capacity. But even though it exhibits a longer cycle life, it has a higher self-discharge rate of 40%. These batteries are used in a number of consumer electronics in the form of AA batteries, and they are used in electric vehicles as well. The toxic level within these batteries is low, but they should still be recycled as they contain human carcinogens. Lithium-ion cells are the most recent update of rechargeable batteries within the market. They are 30% lighter than nickel metal hydride batteries and input 30% more capacity. It has an outstanding self-discharge rate of 20% per month. They cannot withstand great temperature of heat, so they are highly flammable under such conditions. They contain human carcinogens and must be recycled as well. These batteries are used within a great number of electronics, such as mobile phones, smartphones, laptops, tablets, and etc. They are also used within electric vehicles, such as electric cars, electric wheelchairs, and aircrafts. They are used within a number of power tools, such as hedge trimmers and sanders as well. Last, lead-acid cells are the most popular rechargeable batteries. These batteries have been proven to be economical and reliable. These batteries are not used within portable applications like other secondary batteries. They are primarily used as automobile batteries and are used within battery electric vehicles, hybrid vehicles, and golf carts. They are also used within submarines and backup power supplies. A big downside of these batteries is that they are highly toxic and should not enter the waste stream. The lead is now being cycled properly for the continuation in making these batteries.
The general parts of a battery include cathode, anode, and the electrolyte. The anode is filled with electrons, which makes it negative. The cathode has lesser or no amounts of electrons, which makes it positive. The electrolyte, also called a paste, is the liquid inside the battery and also in between the anode and cathode. The electrolyte is what prevents the electrons from the anode to travel directly to the cathode. Thus, it acts as a barrier. The way that batteries give electrical energy is by the electrochemical reactions. This is the movement of electrons going from the anode to the cathode. Since electrons cannot go from the anode to the cathode directly, the electrons have to find another path. The picture shown below has a diagram of a simple circuit. The circuit is placed to allow the electrons to travel to the cathode. Another thing to note is the oxidation and reduction reactions, also known as the redox reactions. These two things happen simultaneously as the animation shows below. The anode oxidizes because it loses its electrons while the cathode reduces. The cathode reduces because it is positive, and when it gains electrons, it becomes more negative. As stated earlier in the presentation, there are two types of batteries. There are primary and secondary batteries. Primary batteries are known as dry or non-rechargeable batteries. One specific example I will discuss is the flashlight because it uses the carbon zinc batteries. This battery is made up of a zinc shell, which is the anode, a graphite rod, which is the cathode, and a mixture of ammonium chloride, zinc chloride, and manganese dioxide, which is the electrolyte. In the following reaction, electrons go to the cathode as any other electron would when it is turned on. The zinc shell becomes zinc 2 plus aqueous plus 2 electrons. Simultaneously, the graphite rod also has a reaction with the ammonium and the electrolyte. The ammonium with 2 electrons coming from the cathode turn into nitrogen trihydride plus hydrogen gas. This places two types of gases in the battery. This can be dangerous because it can make the battery explode. Although the battery could explode, it doesn't because of two other reactions that occur. Nitrogen trihydride reacts with zinc 2 plus to create a molecule zinc 2 nitrogen trihydride to 2 plus aqueous. which solubilizes the gas. Hydrogen gas reacts with solid manganese dioxide, which fixes the hydrogen gas by making solid manganese oxide and water. Moving on to the secondary types of batteries, there are known to be rechargeable. One specific example I will discuss is a lead-acid battery, which is the same as a car battery. This battery may seem a bit more complex because of the way it looks and is made. However, it is not that different from the carbon zinc battery. As we all know, the car battery is big and heavy. Inside, there are lead and lead dioxide plates with sulfuric acid and water. The lead plate is the anode, so it is a negative plate, and it also has a spongy lead surrounding it. The lead dioxide plate is the cathode, so it is the positive plate. The liquid in the battery, which is the sulfuric acid and water, is the electrolyte. The battery begins to send electrons to the cathode the minute someone turns the key on the car. In this case, the lead plate sends these electrons to the lead dioxide plate. The reaction should be lead turns to lead 2 plus and 2 electrons. It isn't that way though. Because of the sulfuric acid present, the lead on the lead sponge joins with the sulfuric acid and creates a precipitate that is not soluble. Thus, the final reaction is lead sulfate and 2 electrons. The diagram shown below should help visualize what actually happens. Simultaneously, as the lead oxidizes, the lead oxide reduces into lead 2 plus and water. However, as before, we have sulfuric acid. Thus, the 2 electrons, a lead oxide and 4 hydrogens, react with sulfuric acid and turn into lead sulfate and 2 water molecules. This concludes the process of powering a car. Once the car is turned on, the fuel power keeps the car moving and the battery does the other minor jobs. When the car is turned off, all of the reactions reverse themselves and recharge the battery. In this way, the primary and secondary batteries are different. The primary batteries cannot reverse their reactions because they have no insoluble products, and secondary batteries do.
Batteries can come in many shapes and sizes. Some batteries are as small as a button, while others can be as big as a brick or cinder block. In everyday life, we use batteries for a large variety of purposes. We use miniature batteries to power our electric watches, calculators, and implanted medical devices. Humans use other types of batteries for various portable devices and equipment. Flashlights, toys, power tools, mobile phones, laptop computers, portable radios, and televisions all use 2-watt to 100-watt batteries. SLI batteries, which stands for starting, lighting, and ignition, are mostly lead-acid batteries, and they can be used to power our cars, trucks, buses, lawnmowers, wheelchairs, and even robots. Stationary batteries, which have between 250 watt to 5 watt, can run emergency power systems and communication base stations. Batteries are even used in our military and aerospace programs. These wide-range batteries have the power to run satellites, robots, and wide-range communications. Submarines use batteries as well.
Alright, so here we are at the pros and cons of battery usage in our modern society. Batteries have been seen as a problem in terms of recycling and waste management for many years because the chemicals that are used in them, such as nickel, cadmium, lead, and mercury, are toxic to humans. They cause soil and water pollution. They're classified as a hazardous waste, and they cause damage to water, humans, and the overall health of our environment. There are ways to reduce this that we would talk about later, but for the most part, the two types of batteries that you can have, which are primary and secondary, also known as rechargeable and disposable batteries, you need to watch out for how you dispose of them, because if they are disposed of in the wrong way, it just leads to further pollution that just causes so many negative side effects to our world. Batteries affect human health in many different ways. Batteries contain chemicals that I talked about earlier, such as cadmium, lead, mercury, and nickel. These things seep into like our water supply and when they're disposed of in landfills, and this causes negative effects for humans such as liver and kidney issues, skin irritation, headaches, asthma, etc. These issues can be avoided by using different kinds of batteries or disposing of them properly. Most people aren't educated on how you can dispose of batteries or the other options there are to not using batteries with these toxic chemicals in them. Alright, so the two type of batteries that you can buy are rechargeable and disposable batteries. Rechargeable batteries are much better for the environment because you can use them more, you get way more use out of them, even though they still contain the toxic chemicals such as nickel, cadmium, lead, and mercury. They are better for our environment and overall human health because you can use them for a longer amount of time. Disposable batteries, I can't say have any real pros besides the fact of giving you that power you need when you need it, because after they're used, you have to throw them away, which ends up in a landfill, leading to just more pollution to our environment, gets in our water, makes humans unhealthy, makes the environment and the air we live in unhealthy. So if you had to pick between the two, you should always pick the rechargeable kind, if not something that's powered a different way, such as solar power or something else like that. You can reduce your battery usage in many different ways. You can buy or only use products that don't require batteries. There are many different things out there these days that you don't need batteries for. They make watches, cell phones, TVs, many different things that you just wouldn't need a battery for to begin with. Therefore, you don't ever have a battery you would need to dispose of or recharge. Solar energy is something that is growing in our world, and it's a great alternative to batteries. You get the power from the sun that transfers just like any battery-powered thing would. There's also the option to recycle batteries, which isn't something many people do, but you can recycle certain batteries that are made into new batteries. They don't cause pollution because they never end up in a landfill. People aren't educated on recycling them as much as they should be, but that's always an option. They're a little more expensive and harder to find, but in the end, they're worth it for the sake of our environment.